इलेक्ट्रोप्लेटिंग इलेक्ट्रोलिसिस खत्म करने के बाद इलेक्ट्रोप्लेटिंग काफी ज्यादा इजी लगता है बच्चे बिकॉज इट्स अ वेरी मच ऑफ अ कनेक्टेड टॉपिक। इलेक्ट्रोप्लेटिंग में वाहिद डिफरेंस ये है इलेक्ट्रोलिसिस से कि इलेक्ट्रोलिसिस में हम दोनों इनर्ट इलेक्ट्रोड्स यूज कर रहे थे, ठीक है, और इलेक्ट्रोप्लेटिंग में हम ऐसा कर रहे होते हैं कि एक मेटल को कोट कर रहे होते हैं सरफेस पे दूसरे मेटल की, और वो फैक्ट कि हमने एक अनरिएक्टिव मेटल कोट किया है सरफेस ऑफ कैथोड पे इलेक्ट्रोलिसिस के जरिए से, इसको प्लेटिंग कहते हैं, चोजन मेटल की इलेक्ट्रोप्लेटिंग द प्रॉपर टर्म, ठीक है। और एलॉयज में मेटल्स एक दूसरे के साथ मिक्स हो जाते हैं, लेयर्स बाय लेयर्स नहीं आते। इलेक्ट्रोप्लेटिंग इस लिहाज से यूजफुल है कि वो लेयर बाय लेयर आते हैं, 1 2, वो स्टिक करना उनका प्रॉब्लम नहीं होता क्योंकि हमने इलेक्ट्रिसिटी की हेल्प से ट्रैक्शन करवाई होती है, तो मेटल्स एक दूसरे के साथ भी प्लेटेड रहते हैं या कोटेड रहते हैं। इलेक्ट्रोप्लेटिंग के लिए इलेक्ट्रोलिसिस सेल को अडैप्ट किया जाता है और उसको चेंज किया जाता है। उसका चेंज जो है वो इन्होंने नेक्स्ट पेज पर, हमारे पास पेज नंबर 112 बनता है, bullet points में बताया हुआ है। So this big portion is very important and has been repeated in past papers way too many times. इसमें क्या है हमारे पास 3 basic rules हैं. The basic rules are, if you're going to electroplate an object with metal M, the object must be made the cathode. Electrolyte must be a solution of the salt of metal M, and the anode must be made out of a strip of metal M. So these are the third rules, and if we follow these rules, we can electroplate an object with a desired metal. Let's take an example. Let's say we are to, just a second. We are to electroplate a jug or something with a specific metal. In that case, what we need to do is to make that object, that jug, or let's say a watch, the cathode, and we'll make that, let's say we have a jug that we need to make electroplate, and let's say we need to electroplate it with gold, so we'll have an anode made out of gold. This will be gold, and we'll have that jug. This jug would be cathode, and we'll dip them in a solution. Let's say the solution is silver chloride, gold chloride, my bad, gold chloride. So the object is made the cathode first rule. The electrolyte is a salt of metal M. This is our metal M in this case. This is our object in this case. So the electrolyte is a solution of salt of metal M. That is the second thing. And the strip of that metal M is used over here as anode is the third and final objective that we need to follow. Just like in this diagram, they are actually going to electroplate all of this with this metal. I think they are probably electroplating it with chromium, and we're not going to study that. What are the benefits of electroplating? So let's check it out. The most common used electroplating is of copper, chromium, silver, or tin. Let's starting with one person. Purpose of electroplating is to give a protective coating on the metal underneath. For example, tin plating of steel cans can prevent them from rusting. This is also the idea behind chromium plating articles such as car bumpers, kettles, bath taps. You've seen their shiny finish and their attractive appearance. So they do not corrode because chromium does not. It's a hard metal, so it resists scratching and wear and tear, and it can also be polished to give an attractive finish. These are the 3 benefits of chromium plating. This rusting prevention is the benefit of tin plating. So Every kind of plating, whether it's copper, chromium, silver, or tin, has their own benefits. I hope you understand that gold plating had its own benefits. That's why there are so many wristwatches, cell phones, cars that are gold plated. Of course, the attractive appearance and the increase in cost of this specific product is one of the very lucrative parts about it. The attractive appearance of silver can be achieved by electroplating silver onto an article made from cheaper metals such as nickel, silver. The EBNS that is seen on cutlery and other objects stands for electroplated nickel silver. Nickel silver is actually an alloy of copper, zinc, and nickel. It contains no silver at all. It is often used as base metal for silver plated articles. So it's actually a cheaper alternative and an alloy of the requirement. So this completes for us electroplating, but yet there is some parts of the topic that are still left to be covered. If we take a look at these reactions in electrolysis, the oxidation of non-metal ions always takes place at the anode. However, the reduction of metal ions always takes place at the cathode. The exception are hydrogen ions. Hydrogen ions are the only non-metal ions whose reduction is take place at the cathode. So this is the common type of redox reactions that we see occurring in case of electrolysis. That's why he has also discussed the products of concentrated hydrochloric acid and very dilute hydrochloric acid for its products at anode and cathode respectively for both of them. This we discussed yesterday, so let's not waste time on it. Let's move on. Next up is the refining or purification of copper by electrolysis. Now, this is more of an electroplating technique. A cell can be set up to electrolyze copper to sulfate solution using copper electrodes, not graphite. As in graphite, electrolysis would take place, and in copper electrodes, electroplating would take place. In case of electroplating, the reaction at copper would be that copper ions from the solution would gain 2 electrons and form copper and deposit at the cathode. At anode, however, which loses masses as copper dissolves, so copper solid, I mean copper atoms, will be converted into copper ions by giving out electrons. So slowly, this impure copper anode would be would shrink and will give away a lot of copper. This copper would go to the solution. The copper ions from the solution will get attracted to the cathode. And as you can see, the before and after parts of this diagram, the pure copper cathode has gained its mass and actually increased in size. The acidified copper sulfate solution worked as an electrolyte acidification so that we can increase the conductivity of the entire solution. But as it's impure copper, it contains many other metals which then fall to the bottom by the name of anode sludge. Continuing on the next page, you would see on page number 114, they talk about that copper is used in electrical wiring and it has to be 99.99% pure. Copper made by roasting its sulfide ore in air is about 99.5% pure. So this level of impurity cuts down electrical conductivity significantly. However, if we go with blocks of this impure metal used as anodes in a cell containing acidified copper to sulfate solution, the cathode are made of thin sheets of pure copper. During the refining process, pure copper is moved from impure anodes and it deposits on the cathode. We use multiple plates like this to be dipped at the same time. Any impurities fall to the bottom of the cell. This material, which we are calling anode sludge, consists of many important precious metals such as gold, silver, and platinum. These can be purified from the sludge, so the sludge is not wasted, instead sold for a good price to another company who can go ahead and take out all or any precious metals from it to be used properly. This finishes the topic of electroplating as well as electrolytic refining of copper for us. And this also finishes chapter 4 for us.